So welcome back. So in previous class we have seen about the sequential circuit, some definitions like what is meant by state equations, output equations, state diagram, state table, like that. So all these three are used to represent the characteristics of the sequential circuit. Okay, that is the characteristics can be represented through state equations, state table and state diagram. Now whatever the example we considered, okay, the slide also showing here one state diagram. It is for the uh, sequence detector. So this is the state diagram for a sequential detector. So that now I am going to represent this state diagram or sequential circuit action, this example sequential circuit action using VHDL language. Okay. Okay. As you know, first of all, you have to write the library IEEE semicolon. Then use IEEE dot standard logic 1164 all. After that, entity declaration as usual. That is, the entity declaration is like start with the word entity. Name of the entity is usually the digital system for which we are going to write the program, that is sequential detector is. Then the port includes all inputs and outputs. Here different inputs are, say, X input, clock input, of course clear input also here we have, and different outputs like the first D flip flop Q1, second D flip flop Q2 and Y output. Okay, so for these signals the modes is represented with the words in, out like that, and data type all are with the standard logic data type, that is the binary. All the ports accepts the binary values. Then end entity name, that is end sequence detector semicolon. Okay. So after that we have to write the architecture body, but here the architecture body can be represented in two different ways. In the first one case I just used the state equations, whereas in the second one case I followed as per the state table. So whatever it may be, the architecture start with the word architecture. So architecture followed by architecture name, that is behavioral here of entity name. Entity name is, what is the entity name given in previous slide? That is sequence detector. Sequence detector is. Then architecture begin. After that, here the model is your behavioral model, hence the preferable statement is process. Okay, process of clock signal, that is the process statement execution depends on the event occurring in the clock. When the event occurs in clock signal, then only the process statement will be executed, otherwise it will not execute. Okay, so process of clock then begin. After that I am going to check the clear signal. If clear is 1, then what we are expecting is the reset state in both the flip flops. That is Q1 is 0, Q2 also 0, and not only outputs of the flip flops, the total system or circuit output also 0. That is Y is equal to 0. Okay, so if clear equal to 1, then the flip flops are in the reset mode, so Q1 is 0, Q2 is 0, and the total circuit output also 0, therefore Y is 0. Okay, else what will happen? Else it has to work out as a sequence detector. Okay, that too, it follows the rising edge of the clock, so therefore, and that means, what is the rising edge of the clock means? Whenever the positive or rising instant happen, rising means changing the clock signal from 0 to 1, that at that instant only the execution will be done, otherwise no. Okay, so therefore else if rising edge of the clock is available, then rising edge of the clock is available, then Q1 equal to whatever from the equations, from the previous equations, we can write it as X and not Q2 and not Q1. Sorry. Or another product term, this is the third product term, or and this is the second product term, first product term, second product term, third product term. Previously we have derived some equations, right? So those equations directly here represented like data flow model. It is almost a data flow model, but the operation depends on the clock signal. That's why we have taken the process and if statements. Okay, and not only state equations, output equation also represented, and after that end if, end process, end behavioral. That means the statements here which we are using in this behavioral case here are signal assignment statement, same signal assignment statement, but here the execution is sequential. Okay, sorry. Okay, so this is the way how the program for the sequence detector will be written using signal assignment, sequential signal assignment statement in the statement process. Okay, so see also another representation is represented here, that is here also first of all library IEEE use IEEE dot standard logic 106 entity sequence detector is the different inputs X, clock, clear, Y. Okay, X input, clock input, clear input, Y in output, but not showing the Q1 and Q2 here. Okay, direct total output of the system will be represented. Okay, then end sequence detector. So after that, architecture body. The architecture body is like this. Architecture name of sequence detector is. So here, you know, the sequence detector has four states: 0, 0, 0, 1, 1, 0, 1, 1. So in order to represent those states with the letters like A, B, C, D, so first of all I am going to declare my own data type for different states. For that purpose I am using the type command or type statement, that is type. My type name is state type is, it includes different values like A, B, C, D. After that I am going to declare one signal object with this type of data type, that is signal state colon, what type of data type? State type. State type, what is state type? It is my own data type. Okay, I declared it including the values A, B, C, D, and assigned with initial state is A. Okay, like that user can declare his own data type and also declaring an object of signal with that data type, assigning the value. Then begin. So declaration is over with architecture. So begin. Then process of clock signal as usual, in previous case also you can same. Then process begin. So after process begin, I am going to check the clear signal. If clear equal to 1, then what is the initial state? That is A. Okay, so the state equal to A and expected output is 0. Up to this it is similar to previous model of program. Okay, else means suppose if clear is 0. If clear is 0, actually the sequence detector action we will expect with reference to rising clock edge, rising clock instant or clock edge, like that. So else if rising edge of the clock, then rising clock edge of the clock, then. So here with observing the input value, the output state will be represented. So this program is as per the state table. Suppose if x is 0, then in order to know the state of the signal object state, I am using the case statement. Okay, case state is when A. Suppose if the state is A, What is the next state under the zero input? Under zero input, suppose if the system is in state A, what is the next step? Also A. If it is in B, comes to A. If it is C, comes to D. When others means if no state in the state means it maintains same preset state, that is A. Then end case. Similarly, under x equal to 1, what is the state transition we will observe in the state table? The same will be represented like this. Okay. Then finally, end if, end process, end architecture name. Before that, if x equal to 1 and state is D, then y equal to 1. Okay, one more condition here is if x equal to 1, that is input value is 1, and also suppose if the state is D, then y equal to 1, that is output equal to logic 1, else y equal to 0. So else y equal to 0, and if for first if one more end if, then end process and behavior. So like that, so using the state equation data and also state table data, we can develop VHDL program for the sequential circuits. Okay, are you clear? How to write the VHDL program for the sequential circuit using state diagram, not the state diagram, state table data. If whatever the program we just discussed now is the program with reference to state table, the previous program is as per the state equations, Okay, so that is the way the VHDL program will be developed for the sequential circuits. Okay, and in the next class we will see the timing in sequential circuit with reference to time. Two types of operations we can observe, that is synchronous operation and asynchronous operation. And before going to that, this is the synthesization result of sequence detector using Vivado design suite. Okay, synthesization result, the synthesis result of Vivado design suites for the sequential detector includes like this. Okay, thank you.